Hi everybody. Earlier we saw that stacks are a last in, first out, or LIFO data structure where items are added and removed from the end. Contrasting that partially, we have another very popular data structure known as the queue. And in this video, we'll get all into it. Now, before I go further, I should let you know that if you want a friendly and comprehensive look at data structures and algorithms, my book on this topic, Algorithms, Absolute Beginner's Guide, is just what you need. Look for it in paperback and Kindle editions, in physical bookstores, as well as online bookstores. So keep an eye out for it. Now, getting back to our topic at hand. So when we learned about stacks, we were using a real world example. We looked at how a stack of pancakes and how we place more pancakes on top and how we eat them can help us better understand how the stack data structure works. With queue, we have another real world example that we can refer to. Standing in line is that example. And here's why. As standing in line goes, the person standing at the front of the line is the first one to have likely shown up, and they're the first ones to leave as well. As new people get added to the line, they show up at the end, and they don't leave until they make progress to the line where each person in front of them gets processed, and then they are finally the last one to actually be processed as well, and then they are done. And so queue follows what's known as a first in, first out policy, and this is commonly shortened to FIFO. Now, turning the tables a bit, shifting from an example of staying in line to our data, let's start with how we can populate data into a queue. So you start with 1, and then as more and more people get added to our queue, they just keep getting added to the end. So you have step 1, you have 2, then 3, then 4, and 5. And at the end, if you look at our queue, we have the data 5, 4, 3, 2, 1, or the start of our queue is 1, the end of it is 5. Now, if this looks very familiar to you, it should, because it's exactly how stacks and how data gets added to a stack data structure. Now, where things are different with a queue though, is how items are removed. When it comes to removing items, notice that the first item is the one that gets removed. So in this case, we have our full queue. We have items 1, 2, 3, 4, 5, where 1 is the first item. So removing it, 1 gets removed first, then 2 gets removed first, and 3 and 4 and 5. You can see how this mimics our idea of standing in line, where you can imagine the bottom of the stack is the, let's say, ticket counter, and then every item after it is the person standing in line afterwards. So the queue data structure is pretty simple in that regard, in that how things get added, how things get removed. Now, when we look at the common operations and their performance characteristics, they're again going to look very similar to that of a stack, but there's one caveat. It's a really big implementation detail, and that is this. For a queue, because we're removing items from the beginning of a collection of items, they are typically implemented using a linked list. Not an array, but a linked list. And we'll talk more about that shortly, but you can see how adding an item, which is adding an item to the end, is constant time, doesn't take up much effort, you just one operation. And removing items, again, is a very constant time operation as well, where we take an item from the front and remove it. This is where the linked list really comes in. And taking a peek at what the next item is, also very fast. Searching, you gotta search through every item in between, there's no index position like item. And memory, the more items you have, the more memory it takes, but it doesn't grow abnormally beyond just the number of items we have. And so the detail to call in mind again is that queues are typically implemented with linked lists. And the reason is this, that operations that involve modifying the front of our list will take linear time with an array. Whereas with the linked list, they take only constant time. And that's an important detail. And these little details will keep cropping up, where that underlying data structure that is used to make the other data structure, like in this case, our super data structure, the queue work, will play a big role in its performance characteristics. So just the story just keeps getting more interesting, right? And if you have any questions, learning about data structures and algorithms is often a team activity. And so what better place than an online community willing to help you out? So check out the forums at forumgroup.com, where I and others will be happy to help you out. And here are some quick actions you can take to go deeper into the topics we just saw, or to just keep up with all the content that I regularly create and share. And with that, I will see you all next time.